Okay, guys, so we're going to get started. In terms of announcements, we're still working on the wait list and finding larger rooms to let everybody in. Worst case scenario, we're not able to find larger rooms. We get to add 11 people off the wait list. That's what it sounded like. But hopefully we're able to find those larger rooms and able to get more people in. If you're looking for the lecture recordings, again, there's nothing official. So we have our own website on YouTube where the lectures will be uploaded. It's UCDCS. So go there if you're looking for the classroom lectures, or also if you're looking for the setup videos, tutorials as well to get set up. If your petition is still outstanding, again, you need to see me by the end of day Friday to talk about that, by office hours. If not, I'm going to kick you out of the class if it hasn't been resolved yet. And let's see. For the Unix tutorial, like the ruptime command is not working. Don't worry about that. If you're running Linux or Mac, you can just do the work directly on your own machine. No need to SFTP in or SSH in. You can do it there. It's perfectly fine. And if you have to submit multiple files, make sure when you zip the files, you zip the files together. So if I wanted to zip these two files together, I would select both of them, right-click and zip them. If I would not want to say zip the folder there inside, because if you zip the folder there inside, we're not able to find your files, and so it sounds like they're missing to us. So make sure you zip the files and not the folder. Any questions before we get started? Yeah. TA office hours will get at the end of this week. Anything else? Okay, your homework, first homework is available in addition to the Linux tutorial. So make sure that you're working on that and you get started. And we'll actually start covering some basics of C today. So actually want to open up a different project. So first thing I want to show you is just some different types and different printing. So one thing that's different about C than Python is that in C and in C++, all of your variables are statically typed, whereas in Python, they're dynamically typed. So what that means is that when you declare a variable to be of a certain type in C, its type will always be that and will never, ever, ever change. Whereas in Python, the type of a variable might be able to change as the program's running. X might first start with a number, like 6, then you might have it have the string hello, then it might be a list of numbers, 12, 33, 99. Its type is changing as the program runs. But in C, if something's an int, it's always an int and will never be anything besides an int. You can't put anything else in there. Your basic types are int for integer, char for a single character, double for real numbers, and there's also float, which you could use for real numbers, but in this class, if you have to use real numbers, we use doubles. Doubles have more precision and a wider range of values they can represent than a float. The trade-off is they're twice as big. They are 8 bytes versus the 4 bytes of a float, but we're not going to really be worried about space issues here in this class. So in terms of arithmetic, most of the operators between C and Python are transferable. Plus is addition, star is multiplication, minus is subtraction, the percent sign is mod, the divide sign is divide. There is no exponentiation operator though. You can't do star star anymore. You have to use the POW method, which we'll talk about in 1 second. And there's also, you have to know explicitly when you're doing floating point division versus when you're doing integer division, right? Do you guys remember how to do floating point division in Python? It's a single slash, right? You want to do integer division? 2 slashes, slash, slash. In C, you have to pay attention to the types to make sure what's happened. So here we have some adding. %D stands for decimal number, base 10 numbers. That's what you use for integers when you're printing them out and later on when you're reading them. Your floating point numbers, your doubles, are LF. The L stands for long float. And then this 0.2 right here means that I only want to display 2 numbers after the decimal point. If you leave it off, it's going to display as many numbers as it wants, but you're actually able to configure how many will be displayed, and it will do the rounding as appropriate. If you add letters together, you could add letters together if you wanted to. It'd be kind of weird. But if you add a number to a letter, it will advance you that far down the alphabet, or actually more explicitly, that far in the ASCII table. So this is the ASCII table. It's going to tell you basically what's the decimal and hexadecimal encodings of each value. So for example, over here we have A, and A has the decimal value 65. So capital A and 65 are basically interchangeable. They're the exact same thing. Or if we look over here at lowercase k has the decimal value 107. So 107 is K, and K is 107. There's no really distinguishing value that C does between the two. They look the same to it. So for example, if we have A, right, which is 97, and we add 3 to it, we do 97 plus 3, we get 100, and then we're going to get D, right? Well, that's 3 letters after A. D, so that should make sense too. So do pay attention to that. You can also notice that it's pretty nice in that all of the alphabetical letters are next to each other. So A, B, C, D, E, F, G, right, all the way down to Z. The numbers are next to each other as well. But also notice that the lowercase or the uppercase letters have a lower value than their corresponding uppercase values. So for example, if you compared big Z, it has the value 90, with little a, the value 97, big Z comes before little a because 90 comes before 97. So watch out for that if you're trying to do like comparisons between characters and you want them to be case insensitive. You either need to make all the characters uppercase or lowercase before you do your comparisons so you don't accidentally have that mismatch. Or if you do care about case, then it'll compare it using their decimal values. Any questions so far? Yeah. So if you want to do something like Unicode characters, you have to choose something besides a character because a character only allocates 1 byte worth of space, and a Unicode character is about 2 bytes worth of space, so it's not big enough. There are probably some libraries or applications for entering in Unicode characters, but you'd have to like Google C Unicode characters or C++ Unicode characters, and you'd find something out there. Yeah. A double is used to represent real numbers. It's just twice as big as a float, and it's 8 bytes as opposed to the float's 4 bytes. But that extra space allows you to have a wider range of values you can represent, as well as more precision within the values. Any other questions? Again, also to note is that multi-line comments, right? /*// math.h gives us some options for doing math library things like POW, as well as sine, cosine, and other things as well. And your program always begins at the function named main. Always, always, always at main. It will not start anywhere else. And again, there can only be a single main, and main's return type needs to be an int. You can, when you're declaring a variable, you can say int and initialize its value to be something. And if you want to, you can declare multiple variables on the same line of the same type by separating them by commas. So you can see here I have int1, comma int2, and they've both been initialized. Same one as num1, num2, and the letters. So again, you can do subtraction. Sometimes you might want to do subtraction between characters to figure out how far apart they are. And then you also can use the subtraction to move backwards in the alphabet, or backwards in the alphabet. Multiplication is star. I'm not sure why you'd want to, but you can multiply, characters and numbers together. There's nothing illegal about that. C is not going to complain. It's just going to use the ASCII value for that character, right? So if we looked at F, which is our value for letter 1, right up here, let 1 is F. If we look over here for capital F, it has the value 70. So really when I'm saying capital F, I'm saying the number 70, even though it's the letter F. So it's kind of weird. Python would definitely be complaining about types at this point. You can't multiply, well, you can multiply characters and numbers together, it just repeats that character that many times. So that's different behavior, so watch out for that. And then we're talking about, again, division between floating point division and integer division. Whenever you do division between floating point values or doubles, it's going to, or double or float and anything else, doesn't matter. The result is always going to be a double or a float. So you'll be doing floating point division. If you do division between integers, you do integer division. That make sense? Also, is this big enough or do we need to make it bigger? Bigger? Forgot I changed the size so I could actually do work. Do you still need bigger? Okay. And then, okay, division. And then if you want to do exponentiation, don't use the caret operator. Caret is for exclusive OR, bitwise XOR. Some of you may have made this mistake even in Python and gotten some weird values trying to do it. If you want to use exponentiation, use the POW function. So POW num1, num2, it raises this value, this number. This is the base and then the exponent. You have to include the math library to use this. So if we go ahead and run this, boom, 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 then it's happy. You can see a lot of numbers pop up on the screen, right? Like 3 letters after F is I. We can subtract values, get things to appear as we want. You guys have any questions about basic arithmetic or any of the type specifiers like %D, %C? So yeah, there are some other functions that will allow you to like put single characters out to the screen, but the function that you're going to be using for like doing most of your display is printf, and yeah, you always have to do the format specifiers. And as many format specifiers as you have in here, you need to have that many arguments as well. So if you have 3 things over here, 3 things over there. Just like if you were doing this in Python as well, right? You can use like the mod operator on the string to get it to fill in the placeholders. If you want to do that arithmetic kind of stuff with the numbers, you can use the ORD function to get the ASCII value of the character, and then you can use chur to convert the ASCII value of a character back into a number, or take the ASCII value and convert it back into the character. So this is basically doing the exact same things that we were doing before, but in Python. So, go ahead and take a look at that. One of the differences, though, between Python, again, is you multiply a string and a number together, it just repeats that string that many times. Here, right, we don't even have strings yet. We only have characters. Well, you've seen some string literals. But for characters, again, single quotes, strings, double quotes, they do matter. They're 2 different things. And if you multiply a string by a number, it's not going to repeat it. It's going to do some funny things. And if you multiply a character by a number, it's just going to use the ASCII value. Questions before we move on to input? Okay. Oops, that's the Python file. So again, we're including stdio.h because we want to be able to use our input and output functions. So when you declare a variable, like for example, we have cur_age here, you don't have to initialize it. You can leave it uninitialized. It's perfectly legal. Its value that it has is undefined. So if you tried to say print out cur_age right now, I don't know what value would display. Some compilers might default the value to 0. Some might default it to not just be whatever value in memory happens to be there, so you have garbage. But the main rule of thumb is that a variable must be initialized before you can use it. Hopefully that makes sense. Right? You don't want to use the variable if you didn't put anything in it first. So be careful about that. And so you might want to kind of like follow along if you're always doing in Python, make sure you initialize a variable. before you always initialize a variable, because that can help you prevent some mistakes. So the function that we use to get input is scanf. And scanf works a lot like printf in that you specify a format string of what you want your input to look like, and then you have to specify a location to place the value. The ampersand here means the address of variable, and before we get into pointers, just know you got to put the address of there for right now when you're doing scanf, and don't forget it. What the address of operator does is it gives you a pointer to that thing. So you're telling scanf, hey, whatever value you read in, I want you to put at the location of current age. Go copy the value there. When we're doing things like printf, we don't want to print out the location of the variable, we want to print out its value. So that's why there's no ampersand there in the printf. So hey, we say, please enter your age, and then we scanf to get the value in. And so %d means we want an integer number. So whatever that integer number that user enters, it'll be converted from the string representation over to the numeric value, then it'll be stored inside current age. And you have this many years until retirement. Yeah. So the question is, what happens if the user basically enters something that doesn't match your format specifier? More general, right? Like they entered a character, which you asked for a number, right? So if the user enters something that doesn't match with your format specifier, a scanf doesn't read it. And it literally doesn't read it, as in it leaves it there. So future scanfs will pick up that character in the future, right? So like if you had some kind of loop where you're like, please enter a number, right? Then you like scanf %d, and someone enters in a character, that character won't get consumed by the %d because you're trying to match for a number, but that character is still there on the input. So you've now created an infinite loop and you're never able to enter anything new because that character is still there. I know, right? We'll talk about how to handle bad input a little bit later on, but we need loops and stuff first to do it right, and pointers to actually be able to store things. That's what will happen, and I'll show you an example of that in a minute. Any other questions? Yeah. So if you enter a real number instead of an int, it's going to treat it like a string, right? So it's going to keep reading as much as it can until it finds a mismatch. So if you enter in like 5000.10, the 5000 matches the integer, and it will leave the 0.10 there because the decimal point didn't match with the %d format specifier. Any other questions? %d stands for integer. It stands for decimal number. If you don't like %d because that doesn't like map to int to you, you can also use %i as well. %i for int or %d for decimal number. So any real number, not real number, any like whole number, be it positive or negative. Any other questions? So here, right, we ask the person to enter their height in feet and inches. You can read multiple things at once. So I want a number followed by a space followed by a number. Hopefully that makes sense. One thing to note here is that this space right here in the scanf, it means 0 or more white space characters. So if they enter like 5 space tab space tab 32, totally will match. Because that one space matches with all the white space characters. Or if they enter in like 3 space 5, also matches as well. The other thing is you don't want to do something like %.2 LF in your scanf statements, because this is saying I need you to enter a decimal number that has exactly 2 digits after the decimal point. If you enter in if you enter in a number that has more digits than that, it won't be able to read those remaining digits and they'll be left there. So if they entered in like 30.52978, it'll only read the first 2 digits that came after the decimal number. So make sure you don't put that in your scanf statements. You want the whole value being read in, even if you only eventually later on print out the 2 decimal points. Let me print out how tall they are. You can also specify constants in your scanf statements, like this comma here. I want you to enter number, comma, number. So number, comma, number, that's what I want. You just specify it there. Again, the white space here means any amount of white space that the user want to enter. So some number followed by 0 more white space characters, followed by comma, followed by 0 more white space characters, followed by another number. So 3, 4 works. 3, space, tab, space, comma 9 works, right? 3 space, comma, space, 22 works as well. One other thing is, whenever you finish typing something, what do you press at the end? Enter. So what might happen if you did this? In case you didn't notice, it went from no space to having a space here. It would match with that new line character, right? But what character do you need to end the input? A new line character. Again, space matches with any amount of white space. So if you accidentally make this mistake and put a space here after the end of the input, you won't actually be able to enter anything. As soon as the user enters the number, they press enter. Well, the enter match with the new line. I'm not done yet. Enter, 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 enter. Right? 0 more white space characters. New line, new line, new line, new line, new line. That's all white space. And so you're stuck here and you won't be able to finish your read. So be careful about that. Don't put spaces at the end of your scanf statements. Otherwise, you'll be stuck there. Or something like this. Oops. What do you think would happen if you did /n? So like they enter the input, they press enter. What do you think happens? Well, yeah, so the first new line character you enter, what happens? Well, what do I say I want? A new line character. So it matches, right? So the input's not being read yet because you had the match. If you put the new line character here, you have to press enter twice. The first enter matches with the new line character you've placed here. The second enter actually like causes the mismatch and you'll move on. So these are like little gotchas to watch out for. Here's an example where we want the user to enter in their initials. So character dot character dot character dot. Right, like MFB, A.B.C, F.B.I, F.B.I dot. Right? And again, they're allowed to enter any amount of white space in between. If you don't put the white space characters here in the scanf statement, they literally have to be character dot character dot character dot, nothing in between. And if that's what you wanted, fine. If that's what you didn't want, and you wanted to allow them to like, do F dot space B dot space space I dot, then this is what you'd have to do. The other thing to also note is that there's this space here in the front of the scanf. So again, like the user might have just typed a number in here, right? They did 35. Then what did they press? What did they type after they pressed the 35? Enter, right? Like they probably like, if they entered a number right before here, then they did like 35 and then they pressed enter, right? To enter in their input. And now you're asking to read an input again. So again, what C does, it's kind of weird, whatever input doesn't match, it leaves there. So since you weren't asking to read a new line in before, that new line's still there. And the new line is a character. So if I have just this %C, I actually read in that new line character and it will match here. And so instead of doing like, FBI, I'll have new line FB as my initials. But here, if I put the space in the front, 0 or more amount of white space characters, that new line that was still left over, that was still there, it gets matched up with this space up here. And so this first character has to be a non-white space character. That was a lot. You probably have questions. Yeah.
Is there a way to like type it? They have to another slowly digest.
You'd have to slowly digest it by keep reading it until there's nothing left. And I'll show you in a little bit, like basically how you could say like read a string of arbitrary length, right? Or if you wanted to make sure after you read something to clear out the input, how to do that. Basically, since we know that most of your input's going to be terminated with a new line character, it involves repeatedly reading one character at a time until you reach a new line. Any other questions? Oh, yeah. So like, they do, yeah, so like here we have like C space dot C, right? And so like if they do like F dot B dot I dot, will that work? Yes, it will work because the spaces there match with 0 or more white space characters. So if they don't enter any white space, it's still fine. Anything else? Okay. So here's an example of like the input not matching, which you guys were asking about before. So here we have some number, it's -99. So I asked them to enter some number with a decimal point. But they enter in 0.36. Does 0.36 match with a decimal number? No, so we actually won't read anything, and so when we print out the value of some num here, what's it going to be? -99, because we weren't able to read in the value because it didn't match. 0.36 didn't match with the scanf statement, so we didn't read the value in. So that 0.36 though is also still going to be there as well. So when we get down to here, we say enter another number that matches with the decimal point. Well, the scanf starts and it's like, oh, hey, there's leftover input here. Let me try reading that. And it's like, oh, 0.36, that matches. And so it reads it in there, and you'd print out 0.36 down here, which I probably actually need to make sure this error is not here. Some double. That makes sense about like if the input is not consumed, it's left there. Okay, it's a weird gotcha sometimes. So let's go ahead and try running this. So if I enter my age, like whatever, then you can enter your height in feet and inches. So maybe I'm like, I don't know, 2'5". Coordinates in the form, 35.30, space, 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 tab, 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 space, 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 tab, 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 comma, 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 whatever. 56. Fully matches. Enter your initials, right? M.F.B. It goes through. So again, this is the problem where I'm supposed to enter something wrong. If I do like 0.36, like I said before, so some num is 9, and then that 0.36 was still there, and so you get the 0.36. Or again, like if you want an example of like why this space is important, I'll get rid of that one space. Whatever. 3,28. Enter your initials, right? And I'll enter the exact same thing that I did. M, or whatever. Now this is going to cause all kinds of weird problems coming on from here on out. Because remember, the new line was left over from when I pressed the enter after this 28. So it's going to match with here. And then, well, now I have an M. Will this M match with a period? No, so this input's going to remain there. And all the other scanf statements are going to find M.F.B. on the input. And so if I press enter, like the program kind of like finishes. Right? Because none of them are able to match the input, but there's input there. And so they keep trying to use it, and they're like, oh, well, I don't match, and they just kind of fail, and they don't initialize the values, and they move on. And I'll show you in a little bit like how to check to see whether you actually read input or not. We talk about validating input. Any questions? And then finally, again, that last problem that I said. So now if I enter my age, whatever, 25, I'm stuck because I put that one little space here. So watch out for that. I think that's all for basically getting input, besides how to validate input, but that requires more information to be able to do that. It's not so simple. Just like if you ever took my class, validating input in Python is not simple either. Any questions before we soldier on? Yeah. So the question is, if you're trying to do like a scanf with like a %D or %LF, will it ignore leading white space? Yes, it will. So %d and %lf do and %f all will ignore the leading white space that happens to be there, which is why things like this still worked down here. This also works too, if you want to be specific. Any other questions? Okay. So you've already seen your first function, it's main. But the difference between functions in Python, the major difference between functions in Python and in C is that in C you can both declare and define functions, whereas in Python you can only define functions, right? Back here in Python, if I'm trying to define these functions, I say def, right? Define this function's name, whatever arguments it needs to take in. But in C, C is a little bit different in that how it runs, in that when you go to call a function later on, it must be either declared or defined before that you can call it. So what I recommend is that you make declarations of all your functions at the top of your files. So this will allow you to make their definitions later on in any order, right? If you didn't do this ordering, then your declarations matter, right? If A calls B, that means B has to be defined before A if you don't do the declarations. The declarations simply say, what's the name of the function? What's the function return? And what are the types and the names of each of its arguments? And again, all of your statements in C have to end with these semicolons as well. So it's just, what's your name? What do you accept? And what's the type that you return? Just like in Python, you can only return a single thing. And if you decide not to return something, you're going to return void, which void means you don't return anything and you shouldn't expect a return value. Other things. Also, like in Python, function names have to be unique. In C++, the actual restriction is the function signatures must be unique. But in C, the function names have to be unique. Questions about your declarations before we move on? Yeah. Void as its return type, yeah. Yeah, you can see like right here on line 55, I have this function doesn't take any arguments, so it has nothing inside of it. You can also equivalently say it's void. It accepts nothing as an argument. Either blank, nothing inside, or void is the same thing. The reason why you have to have your functions either declared or defined in C before you can call them is that C is a one-pass compiler. And what that means is it starts reading your source code from the top to the bottom, and it only goes through once. So if it gets to a function call and it's never seen that function before, it has no idea what to do or whether it's right. And so it'll give you an error about this function not being defined, and it won't compile. Whereas in Python, right, we can do our definitions in any order that we want, and there's no issue. Any other questions? Yeah. That's exactly what I said. You want to make sure you declare all of your functions at the beginning of your file, because then you can define them in any order and there's no problem. The other thing is that like the declarations, besides telling C how to call a function, the declarations are also a promise that you will eventually provide a definition before we reach the end of the file, or the end of your program if it's made up of multiple files. Yeah. So the rule is, so if you declare all your functions at the beginning, the functions can be declared in any order at the top. And afterwards, since they've all been declared, C knows about the names now, and you could define them in any order afterwards. So even though I said trap area is my first function here, is my declaration, trap area could be the very last thing I define. If you don't give the declarations of the functions, then you have to make sure that the function has to be defined before it can be used, because you're not using the declarations, right? And that's going to cause some restrictions on the ordering. For example, if you notice, trap area down here in its definition calls rect area and try area. So if I didn't have the declarations for those two functions up here, C would go down and be like, what the heck is rect area, and refuse to compile anymore, because it doesn't know what that function is. And so if you didn't have declarations, you'd have to make sure that rect area is defined before rect area and try area are both defined before trap area. But if you look at, try area, it calls rect area. You have to make sure that rect area is defined before try area. And this gets really, really tedious to try to maintain and make sure that, there's no dependencies in this order, right? You can see if you have a large project, it would get really annoying because a lot of times, functions call each other. Just do all your declarations at the top and you won't have any problems. Any other questions? So, these functions are just short and sweet. They show you calling some functions, and we define some functions to calculate the area of a trapezoid, right? The area of a trapezoid is a rectangle and two little triangles. So we figure out the area of the rectangle, we figure out the area of the triangle, the two triangles. There's two of them, so we multiply by 2 and we return the value. When you want to give back the value, it's return. If you're in a void function and you just want the function to end, you just do return semicolon. You're returning nothing. But if you return will cause you, just like in Python, to leave the function and give back the value that comes afterwards. One nice advantage, no, that's not true. That would be a lie. Okay. And then again, this is a void function. It just says, hey, enter in the information, right? Scanning them, and then it, calculates the area and prints it out. Calling functions is identical to calling functions in Python. Function name, parenthesis, value 1, value 2, value 3, however many values it needs. Unlike in Python, you can't do optional arguments in C. So every argument you specify has to be provided, and you can't give default values for it like you can in Python. There are also no keyword arguments like there are in Python, so you can't say, like, for example, I couldn't call my rect area and say rect area width equals 10, comma, height equals 9. That won't work in C. You just have to do, 5, comma 9. It is possible in C to have functions that take any number of arguments, but it's really tough to do it well and really annoying to get it to work. So, and you pretty much don't need it for the 99% of the C code you would ever write in your life. So we're not going to cover how to do it. If you do want to find out how to do it, it's called var args. And if we have miraculously some time at the end of this course, I'll show you how to do it. But we probably won't have time. Any questions on functions? And then again, just to remind you, when you're doing the deck, in C, the indentation does not matter. It means absolutely nothing like it does in Python, where indentation is like king and indentation denotes belonging. Your belonging, again, is denoted by these curly brackets. So the start of the function starts here at this curly bracket and ends here at this curly bracket. This curly bracket is from this function. Rect area starts here and ends here. Yeah. So in Python, you can still only return one value. Yeah, but again, you return a list, that's one thing, right? Or if you return like a comma b, what that actually does is it creates a tuple containing the values a comma b and returns a tuple. So again, you're always returning one thing. But there is nothing equivalent to the extraction syntax. So like if you return a list in C that contains 3 elements, you couldn't do a comma b comma c equals that list. It doesn't work. Any other questions? Okay, that's functions. As always, make sure to use them. Tell your friends. So if statements and like if, else if, else, those all exist in Python or in C as well. Just some tiny differences. Instead of capital false, it's lowercase false. Instead of capital true, it's lowercase true. Instead of elif for else if, it's else if. 2 separate words. Not is expressed as an exclamation point in C. And is 2 ampersands, and or is 2 of the pipe character. You should find the pipe character right above your enter key, and you have to hold shift and press that one. One of the other things that you'll see when we're doing the conditions, right, in Python you can write if A is less than B, but in C you have to do if parentheses A is less than B. So when you're doing your condition for your if statement, it needs to be enclosed inside parentheses. The curly brackets are again going to start the beginning and end of that code that belongs to the if statement instead of the indentation. But again, still use good indentation because it makes reading code a lot easier. The other thing is that the inequality operators cannot be chained. You can't do A less than B less than C and have it work correctly. It will not do what you expect. Basically, this statement here is like 99.99% of the time true, even though it doesn't look like it. What it will do is it'll compare A less than B. If that result is true or false, it'll evaluate the true or false. So you'll have true, which is encoded as 1, and false encoded as 0. So you have 1 or 0. Then you'll have basically 1 or 0 less than C. Right? And so not do what you intended. The final thing is that bool variables, the bool type is not built in. If you want to use bools, like the true and the false value, you have to include stdbool.h. So here's just a simple example of the various comparison operators. They're all the same as they were in Python. So you have equals to, not equals to, less than or equal to, greater than or equal to. Nothing should seem too crazy there. And again, notice our if statements, the value and the conditions enclosed inside parentheses, and the code that belongs to that if statement is enclosed inside curly brackets. Again, here's an example of things not working correctly, like trying to do A less than B less than C. If you turn on warnings, which remind me before I go to the next one, tell you how to turn on warnings because it's really important to help you catch more mistakes. This won't actually even compile if you turn on the warnings and turn on the warnings to errors. So if you really wanted to do this kind of expression right here correctly, you have to do value 1 is less than value 2, and value 2 is less than value 3. It has to be expressed that way to be done correctly. When you have the if-else statements, again, they're evaluated from top to bottom. First condition that holds true, that's the one that you run. You will not run any of the other ones, right? It's mutually exclusive, just like back in Python. And again, it's else if instead of elif. Again, you don't have to have else ifs. You don't have to have else paired with the if statement, just like in Python. So you can do multiple if statements, if. If all of them potentially hold true, they will all run. This would be a bad example of using if, right? Because if your age is 1, well, is age less than 2? Yeah, so you're a baby. But is 1 less than 4? Yeah, so you're a toddler and a child and a teenager if your age was 1. And then again, just like in Python, you've probably experienced this exact same problem. Age less than 20, this else is paired with this if statement right here, and only this if statement. Not affected in any of the other ones. Boolean algebra, works just like before, and, or, not, except instead of saying nice words like and, or not, you have to use exclamation point for not, 2 ampersands next to each other for and 2 pipes next to each other for or. One thing to be careful about is that a single ampersand and a single pipe are actually valid C operators, but they're not the same thing as their double counterparts. Like the ampersand or pipe, those are logical ands and logical ors. If you do a single ampersand between 2 values or a single pipe, it will do a bitwise and or a bitwise or. It will and or all the individual bits together, which is probably not what you're intending to do in this class. So be careful about that. Order of operations is just like in Python, not as high as precedence, then and, then or. And one other thing that I should probably mention is that when you have an expression inside the if statement, so the thing that's here inside the parentheses, if this expression evaluates to 0, it's considered to be false. If it evaluates to non-zero, it's considered to be true and the expression will be run. Just like in Python, right? Because if you say in Python if 7, that if statement gets run because 7 is not 0. Finally, again, don't ever do something like this. If a equals 5 or 8 or 9. What's wrong with this? It's always going to be true, right? Because it'll be something like, well, is a equal 5 true or false or not? True or true or true. And this would always evaluate the true, just like it does in Python. And hopefully, you've gotten bit by that bug once in the past and you will not be caught by it again in the future. Hey, we got 5 minutes. Keep sitting there. Do you guys have any questions before I talk about switch statements? Yeah. What is the what? Oh, bool. Okay, so the question is, what does the bool mean? Okay, so what is the thing? Okay, so bool is a type, like int or float or double or char. And so I'm declaring 3 variables here. Tired, have to wake up early, and is weakened. But instead of their type being int or character, their type is bool. Does that make sense? Again, if you don't initialize a variable, its value is undefined. It will compile with warnings. So let's talk about how to turn those on. So this is a command that I recommend that you add to your programs. It's these 2 lines of code right here, and you'd want to put them in your CMake file. And I guess it's actually this. Unhighlight, please. So this is going to add some compiler flags, and like if I try to build my program now with these flags on, it won't actually compile. This first flag right here says turn on all the warnings. The second flag says treat all the warnings as errors, don't compile. A warning is something that is probably wrong, but not wrong enough to make it not know how to translate it into code. So it can do it, right? But it's probably wrong. So you shouldn't have any warnings in your code when you submit to homework, because I make sure to check for that. So if you have any warnings in your code, I will refuse to compile it. And so you address those. So now if I build, it's going to give me some, oh, oops, I built the wrong one. Basic if statements. If I try to build this, it should be like, oh, nope, that's wrong. Right? Doing the value less than some other value. Or here, again, the values weren't initialized. So it's going to complain about them not being initialized before you use them. And it won't compile. So the compiler can be used to catch a lot of errors that you might accidentally have found when you were programming in Python. And if you're here inside a C line, if you click on it, it'll bring you directly to the line that has the problem in it. And as always, remember, that line of code that the compiler reports as having an error, it could be that line of code. But it could also be a line of code that comes before that line that it's expressing the complaint about. So you have to be careful about that. But now if I go back here, if I take off this flag right here, and I try to build it after I reload the CMake file, if I try to build it right now, it will warn me about it, but it will still build the executable. So it'll still build a file there. I could still run it and bad things would happen. So you're going to want to make sure that you have that wall and the error set so that you don't have that issue. We will pick up with this on Friday, and your homework probably will get pushed back over that next weekend because we won't cover enough for you to get it done in time.
But I am on the wait list and I have Canvas and Canvas Wire.
When did you join the waitlist?
Like yesterday or 2 days ago.
Okay, so that just means I need to, if you just like joined yesterday or 2 days ago, I need to update the roster. So I'll do that after class, and then you should be able to do it.
Thank you so much.
And I should stop recording.
So I have a question. So for